This is section 7.5 on solving radical equations. So the goal of solving a radical equation is to isolate the radical or the rational exponent. So we want to try to get whatever has a radical on it or whatever is raised to a certain power by itself using the same rules that you would use to solve any equation, using the opposite operations. Once you have isolated that radical or rational exponent, you're going to cancel it out by doing the opposite and then continue to solve for the variable. You always want to check your solutions with solving radical equations. Sometimes you might get two solutions, but when you plug them back in, only one of them will work. And that's called an extraneous solution if it doesn't work. Okay, so let's look at an example of what a radical equation will look like and not a radical equation. So a radical equation, 3 plus the square root of x equals 10, and then one that is not a radical equation, x plus the square root of 3 equals 10. So a radical equation or an exponential equation is when the variable is raised to a certain power, or taking the square root of a variable, not just a number. Because the square root of 3 is just a number. It doesn't look like it when it's got that symbol on there, but the square root of 3, if I take that and type it into my calculator, it's going to give me a numerical answer. The square root of x, I don't have an answer for that because x is a variable. So radical equations always have a square root or some type of root with a variable underneath or a variable raised to some exponential power. So let's look at some examples on how to solve radical equations. So first I have x plus 3 all raised to the 1/4 power equals 2. So you remember that raising to the 1/4 power is the same as taking the 4th root. It's just another way to write it. So the opposite of a 1/4 power, or the opposite of a 4th root, is to raise that exponent to the 4th power. They will cancel each other out. 4 times 1/4 would just be 1. So whatever you do to one side of the equation, you have to do to the other. So I have to raise the 2 to the 4th power also. So on the left-hand side, like I just said, 4 times 1/4 is going to cancel, and we're just left with x plus 3 on the left. Now on the right-hand side, 2 to the 4th power is 16. Now we can solve the equation as normal. So I would subtract 3 on both sides. So then x equals 13. So like I said earlier, you always want to check your solution, plug it back in to see if it works. So if I plug in 13 plus 3 raised to the 1/4 power, I want to see if that equals 2. So 13 plus 3 is 16 to the 1/4 power. Does that equal 2? So you can either find the 4th root of 16, or you could type 16 raised to the 1/4 power in your calculator, and you're going to get that it does equal 2. So it works. It's a solution to the problem. If you get one that when you plug it back in, it doesn't work, it gives you something weird like 5 equals 7, then it doesn't work. That would be an extraneous solution. Okay, example 2. I have 2 plus the square root of 3x minus 2 equals 6. So like I said at the beginning, we would need to isolate the radical or whatever is being raised to the rational exponent. So I'm going to first subtract 2 on both sides. So that's going to leave me with the square root of 3x minus 2 equals 4. Now, the opposite of a square root is squaring both sides of the equation. So I square the left and I square the right. On the left-hand side, it's going to cancel, so I'm left with 3x minus 2. And on the right, 14 to the second power, 4 to the second power, 4 times 4 is just 16. Now I continue solving. I'm going to add 2 to both sides. So 3x equals 18. I'm going to divide by 3. So x equals 6. So let's go back and plug it back into the original equation. I want to see, does 2 plus the square root of 3 times 6 minus 2 equal 6? So I put that little question mark just because I don't know if it's equal yet. That's what I'm checking to see. So order of operations, we're going to start underneath the radical, and I'm going to multiply first. So this would be 2 plus the square root of 18 minus 2, and I want to see if that equals 6. So now we subtract 2 plus the square root of 16 equals 6. So the square root of 16 we know is 4. 2 plus 4 does equal 6. So since it works, x equals 6 is a solution. Okay, number 3. I have 2 times x minus 2 to the 2/3 power equals 50. So the 2 out front is not being raised to the 2/3 power. It's just 2 times that. So I want to get rid of the 2 first. So that would mean I would have x minus 2 to the 2/3 power equals 25. Okay, so the opposite of the 2/3 power is going to be the 3/2 power. So you just take the reciprocal. So I'm going to raise the left to the 3/2 power and the right to the 3/2 power. Well, on the left-hand side, 2/3 times 3/2 is going to cancel, and that will leave me with x minus 2. On the right, we could do this several different ways. We could type into our calculator 25 raised to the 3/2 power, or remember you could change it to the square root of 25 to the 3rd power, whichever way makes sense in your brain. Since ultimately we're taking the square root in the end of this problem, then I have to put a plus or minus out front. So this turns out to be plus or minus 25 times the square root of 25. And if I simplify that one step further, that's going to be plus or minus 25 times 5, which would just be plus or minus 125. And if you typed it in your calculator from the start, 25 to the 3/2 power, you would get 125. The reason I had to put plus or minus here is because I took the square root of something. Anytime you take the square root of something, it's positive or negative. So now I'm going to add 2 to both sides. So I've got 2 answers here because I have a positive 125 plus 2 and a negative 125 plus 2. So I should get x equals 127 and negative 123. So now I need to check both of those solutions to see if they work. One could work, both could work, neither of them could work. We got to plug it back in to see. So if I plug in and say 2 times 127 minus 2 to the 2/3 power, I want to see, does that equal 50? Inside parentheses, that's going to be 2 times 125 to the 2/3. If I take 125 and raise it to the 2/3 power, that equals 25. And 2 times 25 does equal 50. So 127 is a solution. Now let's try negative 123. If I do 2 times negative 123 minus 2 raised to the 2/3 power, I want to see if that equals 50. So inside parentheses, this would be negative 125 raised to the 2/3 power. So since it's a cube root, I can take a cube root of a negative number. Okay, but then that negative number is being squared because of the 2 on top, so it turns it into a positive 25. And 2 times 25 does equal 50. So both of these solutions work for this problem, 127 and negative 123. Okay, now example 4, I have the square root of x minus 3 plus 5 equals x. So again, I need to isolate the radical, so I'm going to subtract 5 on both sides first. So this would give me the square root of x minus 3 equals x minus 5. So to cancel the square root on the left, I need to raise it to the 2nd power. And I have to raise everything on the right to the 2nd power as well. So on the left, the square root and the square cancel, and I'm left with x minus 3. On the right, x minus 5 squared is the same as x minus 5 times x minus 5. So I need to FOIL this out on the left. The right's going to stay x minus 3. When I FOIL this out, first, outside, inside, last, and I combine like terms, it turns out to be x squared minus 10x plus 25. Well, now I need to move everything to one side. Anytime you have a quadratic equation, you need to move everything to one side to solve. So I'm going to subtract x and add 3 to the other side. So this will give me 0 equals negative 10x and a negative 1x will be negative 11x. 25 plus 3 will give me 28. So x squared minus 11x plus 28. So now I need to factor. So I set up my two sets of parentheses. I know that the two things that multiply to get x squared are x and x. I need two numbers that multiply to get 28, but add to get a negative 11. So I know that's going to be 7 times 4 is 28. And then if I do a negative 7 and a negative 4, they will add to get a negative 11, but multiply to get a positive 28. So when I solve those two sets of parentheses, I get x equals 7 and x equals 4. So now I need to plug these back into the original equation to see which ones work. So let's start with the 7. So if I do the square root of 7 minus 3 plus 5, I want to see is that equal to 7. So the square root of 7 minus 3 is the square root of 4 plus 5. Square root of 4 I know is 2 plus 5. And 2 plus 5 does equal 7. So 7 is a solution. Now let's try 4. The square root of 4 minus 3 plus 5, is that equal to 4? So 4 minus 3 is the square root of 1 plus 5. Square root of 1 is just 1, and 1 plus 5 does not equal 4. So that means that 4 is not a solution to this equation. It's called an extraneous solution. So in my answer, I would just put x equals 7 and not include the 4.